We are going to discuss some important questions which are very frequently asked in board examination for plus 2 candidates in chemistry. See this shades of rule. This is one of the important concepts frequently asked. Second, how malachite green is formed or prepared from benzaldehyde. And third is Thorpe nitrile condensation reaction. So this is the third important question. Then how nylon 2 is prepared. So that is the fourth important question. And how nylon 6 is prepared. So that is question number 5. Then Gabriel phthalimide synthesis, question number 6. And then carbylamine reaction, that is 7. So all these 7 are very, very important and they are most frequently asked in any plus 2 level chemistry, especially in board examinations. Let us discuss one by one. Sides of rule. This is nothing but an elimination reaction. Please take a note of this. Sides of rule can also be called elimination reaction. Elimination means what? That is, one atom is eliminated from the molecule. So this is known as sides of rule. According to this rule, in the dehydrohalogenation, what do you mean by dehydrohalogenation? Removal of HX. Okay. From where? From alkyl halide. Alkyl halide means what? Alkyl halide, RX. And this can also be represented as an example, CH3Br. So in that case, when you have got CH3, CH2Br, what is this? Bromoethane or ethyl bromide. So HBr is removed from this. What is that? HBr is removed. And thereby it forms an alkene. Okay. So it forms an alkene. Now let us go through the definition. In the dehydrohalogenation of alkyl halide. So this is alkyl halide. Example, you can take this one. Or dehydration of removal of water from alcohol. Water, let us consider any alcohol. So here we have two compounds. So one is CH3CHOH and then CH2CH3. Another is CH2CHBr CH3. What about this? This is butyl alcohol, that is 2-butanol. Why? Because 1, 2, 3, 4. So we can write the structure like this: CH3, CHOH, and then CH2, CH3. Okay. So from this, by using sulfuric acid is a very good dehydrating agent. So there is a chance of removal of water. So here you have got this CH2, is it not? So let me write this CH2 as a CH and H here. What happens here? This H plus and OH minus will be removed as water. Do you understand this? So that this bond goes here and it forms a double bond. So it develops as alkene. So CH3, CH double bond, CH, CH3. So this is the reaction. Okay. So this is the what? The formation of alkene. This is alkene. What alkene? This is 1, 2, 3, 4. That is butene, 2-butene. Okay. Do you understand this? And what is the name of this compound? This is CH3, CHOH, CH2, CH3. So 1, 2, 3, 4. Buta. There is an alcohol, butanol. It is in the second position. So 2-butanol. Okay. It is a secondary butanol. OL, remember. So this is a secondary alcohol. Okay. So what is Sayers of rule saying? That is, it talks about the elimination of certain groups or atoms. For example, in this case, H and OH. So it is removed as water from alcohol and thereby you are able to get the alkene. So according to this rule, That is the D, you can split into two. Either you can apply this rule for dehydration of butanol or for dehydrohalogenation of ethyl bromide. In the case of ethyl bromide, so CH3, CHBr, this is not ethyl bromide, this is uh, propyl bromide, is it not? Propyl bromide. So what is propyl? 1, 2, 3 CH3. This is 2 bromopropane, is it not? So you have got 2 bromopropane. So let me explain this. This is, what is this? Alkyl halide. What about this? Alcohol. So from this, when HBr or HX, okay, is when we are able to remove HX from this, this is called dehydrohalogenation of alkyl halide. Are you able to remember this? Okay. So what is this? This is, write down, haloalkane. And what is this? This is hydrogen halide. So minus removal of HX means dehydrohalogenation. Okay, so this is nothing but, that is from an alkyl halide, HX is removed and thereby you are able to get an alkene, that is having double bond. Okay, so this is a compound we are able to get. From alcohol means this is alcohol, where from by removing H2O you are able to get alkene like this. Okay, so for better illustration we can take a secondary haloalkane here, that is CH3, CHBr and then CH3. Okay, so CH3, CHBr, CH3. So you can treat this with the KOH and in presence of ethanol. Okay, so what happens? You can put CH3 as CH2 and put H here. Okay, now Br as Br minus, H as H plus, so that it eliminates as HBr. So that is why it's called dehydrohalogenation. Do you understand this? In this case, dehydrobromination. What is this compound? This is 2-bromopropane. Okay, 2-bromopropane. So here, this 2-bromopropane, from this one bromide anion and H plus, so it is combined as, they are combined as a HBr, so they are removed as HBr by using this KOH in presence of ethanol, and this bond comes here. So it means that is CH3, CH, double bond, CH2. So the result is alkene. So what is this alkene? 1, 2, 3, propene. So 1 propene. Do you understand? And I have already explained about the second type, that is from alcohol, how water is removed to get alkene. So in this case, I have used 2-butanol, that is secondary alcohol. By using H2SO4, you are able to remove water, OH as minus, H as plus. So this bond goes here to form a double bond, where from we are able to get 2-alkene, that is 2-butene here. Do you understand this? So this is called Saitechinfo rule, which is nothing but elimination reaction. Do you understand this? Now let us go through once again the rule. In the dehydrohalogenation of alkyl halide, is it clear? Then forget about this alcohol. Okay, so let us strike out this. In the dehydrogenation, in the dehydrohalogenation of alkyl halide, the more substituted alkene, what is that? The more substituted alkene, the one with the greater number of alkyl groups attached to the double bonded carbon atom is generally the major product. So what do you understand from this? For example, here, instead of forming a double bond other side, so it forms what? A double bond, see that, one with the greater number of alkyl group attached to the double bonded carbon atom. So it forms a bond like this. Okay. Then, so this takes place in the case of substituted alkene. So and then we have already discussed about the dehydration of alcohol. So the same case can be illustrated using that is dehydration of alcohol. So in that case you can reorganize these wordings like that is in the dehydration of alcohol the mode substituted, etc., etc. Okay, right. I hope now you are able to understand the what mechanism behind this. Okay, is it clear? Right. Now you just look at this. You have here CH3 CHOH and this is CH2 CH3. So what is this compound? This is butanol. Is it not? 1, 2, 3, 4 butanol. So this is secondary butanol, that is 2 butanol. From this you are able to get 2, what is that? Butane instead of 1 butane. Do you understand this? Okay, right. And whereas in this case you are able to get that is CH3 CHBr CH3. Okay, so here you are able to get dehydrohalogenation of ethyl bromide. In this case you are able to get only one propene because it has got only 3 carbon atom. Do you understand this? Okay, right. So and I hope now it is very clear for you. Okay, right. Next one, synthesis of malachite green. Listen to this. Malachite green, the structure of malachite green will be like this. You have got a benzene structure, another benzene structure, and this is a quinonoid structure here. Okay, so where you have got N, whenever N is loaded with a plus, it is understood that this is a quaternary like that is nitrogen. That is nitrogen with the plus cation. Okay, clear? For example, nitrogen, let me take ammonia. This is ammonia NH3 and you got a lone pair of electrons. So let us substitute this. This is ammonia. Let us substitute one hydrogen by methyl group. What is that? Methylamine. Another hydrogen by another methyl group. So dimethylamine. Another hydrogen by another methyl group. So trimethylamine. And if you take another methyl group, it has to be donated. A pair of electron is donated. So in that case, it is donated to CH3, another CH3, and thereby it loses an electron. That is why it is called quaternary ammonium salt. This is called as tetraalkyl ammonium. The same situation arises here. Are you able to follow this? Whereas in this case, you have only NH3 type. So when I put like this is nothing but CH3, CH3. So what do you call it? N dash dimethyl. That is the substitution here. Okay, and in this case this is CH3 CH3, but it is having a double bond, and that is why this nitrogen has a cationic nature. Okay, along with that you will be having some chloride ion also, so that you are able to get a salt like this. So remember this structure. Okay, now let me further explain about the structure and how it is formed. Okay, now let me consider the what are the starting material. Let us go one by one. The starting material is benzaldehyde. So how the benzaldehyde can be represented? This is C6H5 CHO. So this is CHO. Got it? Benzaldehyde. What is this? Dimethyl aniline. What do you mean by this? Dimethyl aniline means you have got, that is, this is aniline, NH2, and you have got C6H5. So C6H5 NH2 is called aniline. Okay, take down. So this is benzaldehyde and this is aniline, right? Now dimethyl aniline means these two hydrogens are replaced by two methyl group. So this is N CH3 CH3. Do you understand? and you got the phenyl ring, that is C6H5 group. So this is called dimethyl aniline. I hope you should be able to understand this structure. Okay. Then acid catalyst is sulfuric acid or hydrochloric acid. Now let us talk about the mechanism. The carbonyl group of benzaldehyde. What is the carbonyl group? This is the carbonyl group. The carbonyl group of benzaldehyde undergoes protonation. Protonation means addition of H plus proton by the acid catalyst. So whenever you use acid catalyst, normally such type of catalysts are indicated by simply H plus. It is understood. This is nothing but sulfuric acid or hydrochloric acid. Okay. So acid acid, it is a protonated, making the carbonyl carbon more electrophilic. So in that case, it will be more electrophilic. So more electrophilic means they will be going towards the electron rich center. Okay, electron rich center, because it is protonated, so it will be positive. Okay, so they are moving towards the electron rich center. That is why it's called electrophile. So here the protonated benzaldehyde is the electrophile. Do you understand this? Okay. Then dimethyl aniline. So we have got this dimethyl aniline. This acts as nucleophile. Nucleophile means what? This is electron rich center, and that goes in search of carbonium ion, that is carbocation, that is nucleus center, positive center, and thereby it attacks electrophilic carbonyl carbon of the benzaldehyde. So the result is the condensation of the product. Condensation means that is some neutral molecule like water or ammonia can be removed. So such type of reaction accompanied by the removal of neutral molecule can be called condensation. Okay. So such type of condensation takes place here. And malachite green is a very good dye. So the formation of dye, it involves oxidation. Further oxidation takes place. What do you mean by oxidation? De-electronation is oxidation, that is loss of electron is oxidation. So it can remove further the electron, and there will be a coupling reaction, then the malachite green dye is formed. So the product has a triaryl methane structure. What do you mean by triaryl? Aryl means C6H5 and tri means almost 3 times. So triaryl. Methane is CH4. So here you got CH3, CH4, where 3 hydrogens of methane are replaced by 3 aryl group. So what do you mean by aryl group? C6H5 is aryl group. Okay. So this C6H5, this is phenyl. Aryl means you can take a CH2 also. Okay. So such type of compounds, C6H5, you can simply put 5 also. That indicates C6H5. So instead of CH4, this CH will be there. 3 hydrogens, okay, like this, are replaced by what? The benzene ring like this. Are able to follow? And that is why it's called triaryl. Okay, triaryl. What is that? Triaryl methane. Do you understand this? Right. So again, so I hope now you are able to understand the structure of triaryl, which is responsible for the characteristic green, and especially it has got a, what you call, a quinonoid structure. So whenever you have some quinonoid structure, it gives you deep colors. Okay, this is known as quinonoid structure, and this is the benzenoid form. So instead of having 3 benzenes together, there are 2 benzenes, and one is in the quinonoid form. And this is responsible for deep colors of green because of the conjugated double bond. What do you mean by conjugated double bond? Double bonds are arranged in such a way they are conjugated. Alternatively, they are present so that the pi electron can travel or transfer here and there. Okay, and that is because this deep color is developed. Okay, then so I hope now all points are very clear. Okay, now you have got the C6H5 CHO. What is that? Benzaldehyde, and 2 moles of what is that? That is C6H5 N CH3 types. What is this? N dimethyl aniline. It means it is attached to nitrogen. Why I am very particular about N dash dimethyl? Because this aniline, especially this methyl group, is attached to the nitrogen, not on the benzene ring. When you say simply dimethyl, probably it can be in the ortho position or para position. So you should not mistake it. So in order to emphasize that these two methyl groups are joined in the what? N nitrogen, and that is why it is declared like this. Okay. So by as I already mentioned, the protonation, the malachite green dye is formed. So this is the dye. The structure of dye is like this. You have got the quinonoid form. This is one benzene ring, another benzene ring, another benzene ring, and that is why it is called triaryl. Are you able to follow? At the center, you have got carbon. Okay, so triaryl methane structure, and there are two substitution. One substitution here, N dimethyl. Another substitution is also N dimethyl, but it is what? Having a double bond and N nitrogen with a positive center. Okay, so this is a cationic one. So there will be a counter ion here. So chloride will be attached to this. Okay. So when we illustrate the structure, that is, you are able to get completely the malachite green. You need not worry about the formation, the complete formation of the mechanisms involved in this case. You just remember what are the starting material, and you have to discuss about the structure of malachite green, and the application is green dye. Okay, so this is another aspect. Then now let us go ahead with the third one. Thorpe nitrile condensation. Nitrile group means a C triple bond N group is called nitrile group, cyanide group. Okay, right. So self condensation of nitrile takes place in the presence of a base, leading to the formation of alpha beta unsaturated imine. What is this alpha beta unsaturated? For example, you have got some amino group like this NH2. So here C, C, C. So this is a carbon chain. Now this is alpha carbon saturation, that is a double bond between alpha and beta, and that is why it's called alpha beta unsaturated. And if it is amine, you can say alpha beta unsaturated amine. If it is imine, you can say alpha beta unsaturated imine, and it can be a cyclic compound also. Okay, right. Now the reaction is commonly used in the synthesis of heterocyclics. So heterocyclic compounds are developed in this way, and it is related to Thorpe reaction, involves ketones. Now let us discuss about the reaction mechanism. Base activation, a strong base like a sodium ethoxide. What is sodium ethoxide? That is C2H5ONa. This is called sodium ethoxide. And tertiary potassium tertiary butoxide. Okay, similarly, either this or that. They have the tendency to deprotonate, that is, removing the proton. Okay, the alpha hydrogen of the nitrile, okay, and thereby forming a nitrile anion. Okay, nitrile. For example, let us consider this structure. So what is the structure of this one? R, okay, and then CH2, and then C triple bond N. So this is the what? Cyanide or nitrile. So this is a nitrile, and here what happens? That is, you are adding a base. Okay, by adding a base, what occurs is you are able to get, that is, R, CH double bond C, and you have NH also here, NH and then R. Okay, so such type of compounds are formed, and this is This is called imine. NH2. NH is imine. Are you able to follow? And in the imine, you got alpha and beta. So alpha, beta, unsaturated imine. I hope now you should be able to understand this structure. Okay, what is that? This is alpha carbon, this is beta carbon. In between that, you have got a double bond. So this is called alpha, beta, unsaturated, and this is imine. If it is NH2, that is amine. Okay, right. Then, this is regarding the formation of such type of compound. Okay, then nylon 2. Nylon 2, this involves polymerization of amino acid. What do you mean by amino acid? CH3COOH is acetic acid, and you got the COOH functional group, and this is called alpha carbon atom. In the alpha carbon atom, you got 3 hydrogen. Replacing 1 hydrogen of the alpha carbon atom, you are able to get NH2, CH2, COOH, which is nothing but alpha amino acetic acid. Clear? Alpha amino acetic acid. So generally it's called amino acid. So this involves polymerization of amino acid, especially glycine. Okay, so glycine, which contains both amino group and the carboxylic acid group. You have got amino group and the carboxylic acid group. Are you able to follow? So you have got 2 functional groups here. So using this, we are able to get the nylon 2, and this is a polyamide. Okay, amide means you are able to get the CONH link, that is called amide. Okay, CONH link, right? So amide link, that acts as the backbone. So let us see the structure of this nylon 2. The starting material is glycine. This is called glycine, Glycine. This is nothing but NH2CH2COOH. Are you able to follow? NH2CH2COOH. This is glycine. Okay. Now you have another reagent, that is the omega amino caproic acid. What is this omega amino caproic acid? As I already mentioned, this is a carboxylic acid, and you have got the amino group at the omega carbon atom. What do you mean by omega carbon atom? You know, this is function group. Okay, function group. This is alpha, this is beta, this is gamma. These are all CH2. Actually, CH2, 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 CH2. Instead of putting lot of CH2, I simply put zigzag, that is the bond line formula. Okay. So, alpha, beta, gamma, delta, omega. In omega, NH2 group is attached. So, that's why it's called omega amino caproic acid. Is it clear? What is that? Omega amino caproic acid. Got it? Okay, right. Now, so these two are going to combine. Okay, n moles of glycine, n moles of amino caproic acid. So when they combine, what happens? Now look at this, NH2CH2COOH. This COOH, that is OH from this carboxylic acid, combined with the hydrogen of the amino group, of the amino acid group. So what is amino acid here? This is omega amino caproic acid, and this is glycine. So water is removed, and that's why it's a condensation reaction. Sorry. Now water is removed. Okay, so water is removed. How many water molecules removed? Based on the number of molecules, number of moles. Okay, so now I have represented on this side another molecule is liberated. So I have put simply NH and CH2, CO, NH. So CO and this NH. Are you able to understand? So this CONH group, this is the amide linkage. Okay, what do you call it? This is called amide linkage. Okay, then it follows like this, zigzag. structure, and finally it is terminating with the COOH, but it is not going to be terminated because it is a polymer. Okay, so it is going to be continued. This condensation is going to continue with the next polymers also, I mean monomers also. So in that case, it is going to combine with another NH2. So you can eliminate this and simply put CO dot dot dot. So you are able to get n number of monomers like this. That is why it is developed as nylon 2 polymer. Got this point? But you have to practice all the structures. Okay. So nylon 2, what is the specialty about this? This is biodegradable because it is derived from amino acid, and that is why nowadays it is employed in bioengineering and medical field because it is compatible with all biological system. Okay, right. Then I think we have discussed about the nylon 2. Similarly, you have nylon 6. Nylon 6 here, you have got the caprolactam. It is a cyclic amide. So what is caprolactam? You just count it. This is NH 1, 2, 3, 4, 5, 6. Okay. So a 6 carbon atom and 1 heteroatom, nitrogen. Okay. That forms with amide and keto group. So that is called caprolactam, a cyclic amide. Do you understand this? Why it is called cyclic amide? Because it forms a cycle and you are able to get the NHCO linkage to form a cycle here. Okay, and that is why it's called caprolactam, a cyclic amide. Do you understand this? So what we are going to do this is the monomer and this is the starting material. So it is heated at a high temperature around 250 degrees Celsius. Okay, so thereby you are able to get that is condensation. The ring opening takes place. So the ring opening takes place. So the ring opening means it is broken here, so that you are able to get NH2 here, and you have got CH2, 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 COOH. Okay, that is nothing but aminocaproic acid. So once aminocaproic acid form means again you are able to get the polymer. Okay, so this type of polymer. Now here the water is not eliminated, you must understand here, and that is why nylon 6 is not a condensation polymer, whereas a nylon, other nylon 2, nylon 6, they are all condensation polymer. Do you know why? Because water molecules are removed there. So here it is only NHCO linkage is broken here, that's all, but no water is eliminated here. Do you understand this? So that makes the difference. And this type of nylon, so you have to mention this property, that is water is not eliminated during each step. Okay, rather it is used to hydrolyze caprolactam initially. And this type of nylon 6 is used in the manufacture of textiles, ropes, automotive parts and industrial components. Okay, so particularly for developing for making clothing and carpets. So these are all very useful. And as far as engineering plastics are concerned, automotive components and machinery parts and other electrical equipments are produced using this plastic. Okay, then industrial use, nylon 6 is used in making fishing nets. Then it is also used as conveyor belt. Okay, so likewise it is used in various making various industrial ropes also. Okay, so this is the, now when it is going to be polymerized, you are able to get an ultimate structure like this. Okay, so on this side COOH, on this side NH2. So OH is removed and this one, it is going to be joined, not removal, CONH, it is broken. So it forms a nylon 6. Why it's called nylon 6? Because you can find in each monomer, this is monomer. What is polymer? It is a replica of several monomers, that is polymer. And each monomer you can find 6 carbon atoms, and that is why it's called a nylon 6. Is it clear? Right. Then you should know something about the that is nylon 6 also. Why it's called nylon 6 is different from nylon 6. 6 is different, nylon 6 is different. Okay. Now let me explain about that one also. So here, that is, it is a nylon 66. Nylon 66 is produced by combining adipic acid. Please take down adipic acid and hexamethylene diamine, HMDA, hexamethylene diamine, right? So by combining these, you are able to get nylon 66 repeating unit. Why it's called nylon 66? Hexamethylene means you have got, that is CH2 6 times. Hexamethylene, methylene means CH2, hexamethylene means, and the diamine means on both sides you have NH2 and NH2. So this is the structure of HMDA. So you have got 6 carbon atom here. And what do you mean by adipic acid? Adipic acid nothing but CH2, CH2. Okay, then CH2, CH2. Again, COOH, COH. It's a dicarboxylic acid. This can be represented like this also. Okay, so CH2, 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 and here you have got COOH, and here you have got COOH. This is called adipic acid. You should know something about the different types of, dicarboxylic acid. These are all called dicarboxylic acid. You know the famous carboxylic acid, dicarboxylic acid. Do you know that? Let us discuss that one also. What is the first member of dicarboxylic acid? Anyone? Oxalic acid. Okay. What is this? Oxalic acid. This is the first member of dicarboxylic acid. And what is the second member? CH2, COOH, COH. This is called malonic acid. Okay? Malonic acid. And the next member is CH2, CH2, COOH, COOH. This is called succinic acid. Take down. Succinic acid. Okay? And you have another acid, that is 5 carbon atoms, based on 5 carbon atoms. This is called glutaric acid, CH2, then COOH, then COOH. This is known as glutaric acid. Glutaric acid. And finally you have 1, 2, 3, 4, 5, 6. This is called adipic acid, that is a dicarboxylic acid having 6 carbon atoms. And you can also call by iupoctane. Can you try? How many carbon atoms are there? 1, 2, 3, 4, 5, 6. Hexa. So hexane. Do you understand? So what is this? Hexanoic acid. So there are 2 carboxylic acids. So hexane dioic acid. So 1,6-hexane dioic acid. That's all. Okay. Do you understand this? Right. And similarly, you have now this adipic acid can combine with what? Hexamethylene diamine, so that you are able to get a lengthy molecule like this. So here you have C double bond O, and this is CH2, 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 C double bond O, again N, then H, and again repeating unit 1, 2, 3, 4, 5, 6. Okay, so NH like that. So it is going to repeat like this. Okay. N. So that is why it's called nylon 66. Is it clear? And it will form a structure like this, and there will be cross linking also. Okay. So this is the simplest structure. Okay. So this is regarding nylon 66. So we have discussed 3 types of nylon. One is nylon 2, nylon 6, and nylon 66. Then Gabriel phthalimide synthesis, a very, very important reaction. Gabriel phthalimide synthesis. Okay, take down. Gabriel phthalimide synthesis is used to prepare primary amine from alkyl halide via the reaction phthalimide with alkyl halide. Now let us discuss what is this phthalimide, especially potassium phthalimide. Let me discuss the phthalimide structure. Before that, you should know something about the phthalic acid. Okay. Now listen. This is benzene, right? And you can put one COOH here. What is this? Benzoic acid. Now here you have another carboxylic acid group. This is called phthalic acid. Okay? This is isophthalic acid. It is adjacent, right? But whenever you are able to get such type of carboxylic acid in the vicinity, that is nearby, immediately there is a tendency of removal of water. So it becomes what? Phthalic anhydride. Are able to follow? So CO, this is CO, and here you are built. So what is this? Phthalic anhydride. Removal of water. Okay, note down. Phthalic anhydride. So this phthalic anhydride, okay, when it is combined with NH3, okay, you are able to get phthalimide. So let me combine NHH like this. This is ammonia. Okay. Now what happens here? That is, they can combine like this to remove water so that you are able to get, now see that this is called C double bond O, C double bond O, and then NH. This is known as phthalimide. Phthalimide. So phthalimide. IMED. IMIDE. Phthalimide. Do you understand this? Okay? Right. Now what we are going to do with this, let us consider the phthalimide here, that is you got. So whenever I go out of frame, you please let me know, otherwise let me reduce the magnification. Okay? Right. So phthalimide. So here, let me consider a phthalimide like this, C double bond O, C double bond O, and here you have N, then H. Okay? Right. Now, first thing you have to add KOH, potassium hydroxide. Followed by that, you can take any alkyl halide. Let me take alkyl iodide, methyl iodide. And then protonated water, that is hydrolysis. Third. So H3O plus means protonated water, acidulated. Okay. And thereby, now, first it forms like this. That is, you are able to get N-alkyl phthalimide. Okay. So the first compound is, this H is replaced by R. Got this? And then, so this is the first reaction with the KOH. Okay, because this hydrogen is acidic. So it can react with the KOH. Note down, this hydrogen is acidic. So this is the base, it can react with the KOH so that H is removed. So you are able to get, on adding alkyl group, that is N-alkyl. Okay. எங்க அயோடின் ரிமூவ் ஆயிடுது. இது அந்த ஆர்ஐ இருக்குல்ல, இந்த ஆரில் இங்கே வந்து ஜாயின் ஆயிடுது. அதாவது இப்போ கேஓஹெச் போட்டோன்னா, ஸோ அது ஆமாம் ஹைட்ராய்டு, அது வேணால் போடலாம். ஸோ இங்கே வேணால் போட்டால் இங்கே என்ன ஆகும்னாக்கா சி டபுள் பாண்ட் ஓ, யூ காட் சி டபுள் பாண்ட் ஓ. இந்த இடத்துல என்ன ஆகுது அப்படின்னா என் போட்டுட்டு, ஓகேவா, இன்னும் வந்து இப்போ ஓஹெச்சும் ஹெச்சும் ஜாயின் ஆகிட்டு கேன்னு வரும். ஓகேவா, அதுக்கு அடுத்தது தான் இப்போ ஹெச்ஐ ஆர்ஐ ஆட் பண்ணுறேன். இப்போ புரியுதா? இது நான் டைரெக்டாக போட்டிருக்கேன். நீ இந்த ரூட்டில் வரதா இருந்தால் இதை அழைச்சிரு, இங்கேருந்து வா. ஸோ திஸ் இஸ் த ஃபஸ்ட்டு ஸ்டெப். ஓகேவா, என்கே. ஸோ ரிமூவல் ஆஃப் வாட்டர் வந்துருச்சா, அசிடிக்கா? அசிடிக்கும் KOH OH ஜாயின் ஆயிடுச்சுன்னா வாட்டர் ரிமூவ் ஆகிடும். தென் யூ ஆர் ஏபிள் டு கெட் என்னது N சப்ஸ்டிடியூட்டட் பொட்டாசியம், அங்கே K வருதா? ஓகே, ஸோ பொட்டாசியம் தாலிமைடு வருது. வாட் இஸ் தட்? பொட்டாசியம் தாலிமைடு. அந்த பொட்டாசியம் தாலிமைடில் ஆல்கைல் குரூப் ஆல்கைல் அயோடைட் கம்பைன் பண்ணுறப்போ KI ரிமூவ் ஆகிடும். இப்போ புரியுதா? ஓகே, அப்போ N ஆல்கைல் வந்தாச்சா? ஸோ திஸ் இஸ் கால்ட் N ஆல்கைல் தாலிமைடு. ஓகேவா? ஸோ N ஆல்கைல் தாலிமைடு இப்போ வந்தாச்சு. இதுக்கப்புறம் நம்ம என்ன பண்ண போகிறோம் அப்படின்னா, அங்கே தான் நாம் இந்த ரிடக்ஷன், இந்த புரோட்டனேட்டட் வருது அப்படின்னோடனே அங்கே பிரேக் ஆகுது. புரியுதா? புரோட்டனேட்டட் வாட்டர் போட்டு ஹைட்ரோலைசிஸ் பண்ணுறோம். ஸோ ஹைட்ரோலைசிஸ் பண்ணுறப்போ இப்படி ஆகும். ஸோ அப்போ இங்கே H, இங்கே OH, இங்கே H, இங்கே OH. இப்போ புரியுதா? அப்போ பழையபடி யூ கேன் கெட் பேக் தி தாலிக் ஆசிட். ஓகே, தட் பிகம்ஸ் த தாலிக் anhydride once again. ஸோ அப்போ த மேஜர் காம்பவுண்ட் இஸ் RNH2 amine. வந்தாச்சா? Okay, so this is a very good synthetic work. This is called Gabriel thalamide synthesis. Okay, and resulting byproduct வந்து you have got the thalic anhydride. Thalic acid வரும், மறுபடியும் அது thalic anhydride மாறிடும். Done. So this is the primary amine. So you are able to get the primary amine. So you can synthesize amine based on this by changing the type of RI. சப்ஸ்டிடியூட்டட் என்ன வேணால் பண்ணலாம். அதில் மீத்தைல் வேணால் மீத்தைல் போடு, ஈத்தைல்னா ஈத்தைல போடு, சரியாக போச்சு. யூ ஆர் ஏபிள் டு கெட் த ரெஸ்பெக்டிவ் அமீன். ஓகே, இஸ் இட் கிளியர்? ரைட், நெக்ஸ்ட் ஒன். அடுத்தது என்ன இருக்கு? ஸோ கேப்ரியல் தாலிமைட் ஓவர், அண்ட் ஃபைனலி யூ ஹாவ் தி carbylamine reaction, which is also a very important reaction. So this is also called that is a Hoffman isocyanate test, carbylamine test. It is useful to detect the primary amine, and this primary amine generally reacts with the chloroform and the alcoholic KOH. So this is primary amine, this is chloroform CHCl3, and this is alcoholic, that is KOH. Okay, alcoholic potassium hydroxide. So when it is heated, you are able to get isocyanate. Okay, so when you got RCN, this is called cyanide, right? When R is attached through nitrogen, so RNC means this is isocyanate. Okay, so you are able to get isocyanate like this with the removal of 3HCl, KCl and water molecule. So here RNH2 is the primary amine, that is aliphatic or aromatic, and chloroform is the essential reagent, then KOH is a strong base, and then you are able to get isocyanate, and isocyanate can also be called carbylamine. So this is a very good test to identify whether the compound is primary amine or not. Okay, and that's why it's called carbylamine test. It is very useful for in the qualitative analysis. It's a diagnostic test to identify the primary amine, and is also involved in the synthetic applications like to form the isocyanate, etc. Okay, right? So any doubt?